Okay, static friction. So frictional forces today, we're talking about the force that acts between two solid surfaces. So it's the force that acts between two solid surfaces that are in contact. Those two types of forces are called static friction and kinetic friction. Static friction is the larger of these two forces. It's the force that acts between two surfaces that are stationary to one another. So in static friction, the two surfaces are in contact, but at that moment in time, they are stationary to one another. There's no sideways movement between the two. Now, static friction is unique because this force is a changing force. It's not a constant force. What do I mean by that? I mean that if you start pushing on the object and it doesn't move, the static friction is pushing back with the same amount of force. If you increase the push force that you're applying to the object and it still doesn't move, static friction has increased to balance out your push force. You can exceed the maximum static friction force. To get the object to move, you have to exceed it. But how much do you need to exceed it? If the static friction maximum force between two objects is 10 newtons, then you have to apply 10.0000001 newtons. Would you say 10.0000001 newtons is about 10 newtons? Yeah. So when we start talking about how much force is required to get an object to move, we say it's the maximum static friction force is required to break the static friction and allow it to move. Here, part A, this is the force that must be overcome before an object will begin to slide. So that's what I was just talking about. Now, in a question, and I'm still referring to part A here, there are some, if you would, key terms or code words in a question that lead you to this statement. If there's a problem that says it requires, there's a box on the warehouse floor, it requires 100 newtons to get it to start moving. Not only are they telling you the push force required to get it to start moving, they are also telling you the maximum static friction force. So in code there, they're saying the force of static friction is 100 newtons when they say that is the force required to get it to move. Okay? Could the static friction force be less than 100 newtons? Yeah, if you're only pushing 50 newtons on it, it's only going to push back with 50 newtons. Part B. Static friction is not only the force that keeps an object stationary, it is also rolling friction. Okay, so we just got through saying that the objects are stationary to one another, yet this is the friction that makes your car move forward. This is the friction between the tires and the road. And here's why. When a tire is rolling across the road, so if this hand that's sort of curved right now is my tire and this hand is my road, as a tire rolls across the road, the tire is not slipping. So the surface of the tire is not slipping across the road. It's in contact with the road and it's not slipping. That's stationary. So the two surfaces, the tire and the road, are stationary to one another when the tire is touching the road. Well, this is a good thing because static friction is the greater frictional force, not kinetic friction. So if you want to have the greatest acceleration in your car, you want to use static friction as the force that you accelerate forward with. If you have a very slippery surface and you try to press down on the gas pedal and your wheels start to spin, you may move forward as your wheels spin, but you're going to move forward very slowly because when they spin out, there's some kinetic friction between your tires and the road, but kinetic friction is a lot less. So what's pushing your car forward? It's not really the engine. It's static friction between your tires and the road that push you forward. How about when you walk? What pushes you forward when you walk? You pushing down and backwards on the floor. Well, that's backwards. Which direction do you move? Forwards. So you push backwards on the floor, and what does the floor do to your foot? It pushes you forwards. It's Newton's third law. What force actually pushes you forward? It's static friction. Okay? Because your foot, if you were to walk on ice where there's very little friction, what does your foot do when you push backwards? It slides. And sliding friction is kinetic friction. So you might move forward a little bit when your foot slides backwards, but a very small amount. The friction, yeah, because you're not sliding across the ground. You have two solid surfaces. The sole of your shoe and the floor are in contact with one another. They're stationary to one another. And so it's static friction between your shoe and the floor that actually propels you forward. Something different. But rolling friction is also static friction. Okay? Now, kinetic friction is the friction that acts between two solid surfaces that are sliding along one another. So this is a sliding friction. Kinetic friction is a little simpler because it is a constant force. No matter how much push force you're applying to slide something forward or backwards, this kinetic friction is going to be constant. Static friction balances out your push force until you break the static friction. Kinetic friction is just one constant force. How do I write force of friction? So the variable will be F, so force of friction sub little f. F sub f. So that is one new variable today. Coefficient is also a variable. This is the Greek symbol mu. Looks a lot like a cursive U. Okay. It's a constant. It's going to tell us the potential for friction between two surfaces. So if you have ice and another surface, or you have pavement and another surface, do you think there's more friction between the ice and something or the pavement and something? Probably the pavement. Okay, so this coefficient is going to be larger for the pavement and another surface than it would be for ice. So it's going to tell you what's the possibility or the potential for friction for these two surfaces. Now this is a unitless quantity. Because it's just a constant, it's just a multiple. It's also usually less than 1. So usually it's less than 1. If you have some man-made surface like Velcro, Velcro would have a lot of friction, right? Whole bunch of friction. In that case, your coefficient of friction will be greater than 1. But if we're just talking about two normal everyday surfaces rubbing against one another, it's going to be less than 1. Okay? Now we have an equation. The force of friction, F sub F, is equal to the coefficient of friction times something else. Well, the coefficient is one variable that affects the amount of friction. So the rougher a surface is, the larger this coefficient will be. What's the other variable? So some of you were pulling your sleds with the mass in it. Some of you were pulling your sleds without the mass in it. How did adding the mass to the sled change the friction? Did it have any effect? Yeah, it increased the amount of friction. So the weight of your object affects the amount of friction between the two surfaces. And so here is that variable, and it's going to be the normal force. Call this equation the fun equation. Everyone see why? Yeah, so it's friction is equal to the coefficient, that looks a lot like U, times the normal force. So if I refer to the fun equation, I'm talking about the force of friction equation. Because we have two different types of friction, static friction and kinetic friction, we really only have one equation. How do I calculate static friction versus kinetic friction? It's this coefficient that differentiates between the two. So the coefficient of static friction is mu sub s, that's a little subscript s there, and that means static. And then if you're using the coefficient of kinetic friction, mu sub k, in this equation here, then you'll get the kinetic frictional force. So the coefficient of static friction is mu sub s. The coefficient of kinetic friction is mu sub k. We said that static friction is greater than kinetic friction. Well, we don't change the normal force. What we do is change this coefficient. So that means that the coefficient of static friction needs to be greater than the coefficient of kinetic friction for any two surfaces. So if you're given two coefficients and they don't tell you which one is which, the larger one is always the static. Anti-lock brakes. You all are growing up in a time period where basically all the cars have anti-lock brakes now. When I was growing up, we did not have a car with anti-lock brakes until I went to college, I believe. So when I learned how to drive on slippery roads, I was taught to pump my brakes. Don't put your foot on the brake because you're going to start a skid. Okay, so that's how I learned to drive. But they hopefully don't teach you that now with anti-lock brakes, because anti-lock brakes do the pumping of the brakes for you. What's this about? Why do we care? If your car goes into a skid, your tires are sliding along the road. What kind of friction is being used then to slow your vehicle down? It's kinetic. Okay, which is bigger, static or kinetic friction? Static. Do you want a smaller frictional force slowing your car down? No. So it would eventually slow your car down if you have plenty of roadway. More than likely, it's going to be the car in front of you that ends up slowing your vehicle down if you're in a skid, though, and you don't want that. So we have these things called anti-lock brakes that keep your car from going into an all-out skid, or they try to help deter that. What does it do? When your brakes go on, for a moment, the two surfaces catch and your tire rolls, and you use static friction to slow your car down. But when you break that static friction, when the force is too great, you start to skid, and then you have kinetic friction, and the car computer lets up on the brakes. So it allows your wheels to start to turn again. And you go through this same process. The tires grip, you have static friction, and then the force becomes too much. You break static friction, and your tire wants to skid again. Kinetic friction. We don't want kinetic friction, so you let up off the brakes, the tire begins to roll again. If you physically, humanly, are pumping the brakes like that, it takes a lot more time for you to push your foot on the brake and then let it up, and then put your foot on the brake and let it up. The computer system can do that whole process much more rapidly, and so you have much better success in the end. If you start pumping the brakes yourself, you're not getting the advantage of that computer system and the speed that the computer system can do that at. And then you have much more control over your car if it's the computer system that is kicking in that anti-lock brake system. Have you guys ever experienced the anti-lock brakes? Yeah. Yeah. First time you experience it, I don't know about you, but it's a little scary to me. Even after many, many years of anti-lock brakes, that first time in the winter that I hit the brakes and I feel the anti-lock brakes do their It feels like a vibration, sort of. It's a little scary, but don't let your foot off the brake. Let the anti-lock brakes do their thing. I remember very distinctly the first time I experienced anti-lock brakes. I was driving with a friend up to her college, and we were like 19. And it was snowing really badly. I'm not certain my parents really knew the weather when they let me drive with this friend. We went like 3 states away. So I don't know. I have a hard time picturing allowing my children to do this, but her family was a little better off, and they had a very nice car that we were driving, and it had anti-lock brakes in it. And I'd never experienced this, but it was a snowy road, and there were a lot of cars, and I hit the brakes. And at that time, the anti-lock brake system was this boom, 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 boom. And you could feel it in your foot, and it was a very, very loud noise. Boom, boom, and it freaked me out. I think I screamed. And my friend was sleeping, but I remember that. And it was a good thing there was anti-lock brakes, because we did not have an accident on that day. 19, several states away from my parents, because there were anti-lock brakes, and it worked. But let them do the job. Don't pump the brakes. That's outdated now. So if you learn that way because your parents learned that way, that's really an outdated way of driving now. So you've all experienced this then. Have you experienced an older car that had the loud anti-lock brakes? None of you are shaking your head yes, so. Yeah? The newer ones aren't so bad, but those older ones. Okay, so that's anti-lock brakes, and that's why they're important, is physics. And most of what you do when you drive is all about physics. Heck, when you ride elevators, we've learned it's about physics, right? Now, let's look at this example question on the bottom. So we've talked a lot about conceptually now, friction. Let's go ahead and see what a problem with numbers would look like. So it says there is a block that is 20 kilograms of mass, and it's pushed horizontally with 72 newtons of force, and they've supplied us with the coefficient of static friction and the coefficient of kinetic friction. Again, look at these two numbers. They are small little numbers. They're just multipliers. There's no unit on those numbers, and the static coefficient is definitely larger than the kinetic, even though they're both really, really small. Part A, will the block move from rest? Okay, I don't know yet. We're going to have to calculate this. And part B, if the block is already sliding, so let's disregard what we answered in part A. If it's sliding, what's the acceleration of the block? So we're going to start off the same way we have this entire unit. We're going to draw a free body diagram. So part A, free body diagram. 1, 2, 3, or 4 forces acting on this block, this mass. So we know there's the weight. You guys disagree with how many forces, so let's analyze this. The force of gravity. What do you know about the forces in the y direction? Balanced or unbalanced? Balanced. So what kind of force is up that's balancing out the weight? Normal force, because the ground is a solid surface supporting it. So we have some normal force, we have some force of gravity, so that's 2. And then we are pushing on it with 72 newtons of force. So this is the force of push, and I can actually give that a number immediately, 72 newtons of force. Okay, and then they're telling us that there's friction between the block and the floor because they've given us a coefficient. How big do I need to draw it? Well, it's not moving, so it's got to be static friction. Can static friction, if it's stationary, be bigger than my push force?
Yes.
If it's bigger, that would mean pushing on it, and it pushes back with a greater force, and suddenly the block is going on top of you. You've been pushed over backwards, and we know that doesn't happen. So static friction, if we're pushing on something to get it to move, cannot be larger than my push force. It can be the same size, or it can be smaller. So I don't know how big it is. There's some force of friction, static. I really don't know the size. All that I know is it can't be larger than my push force. So we need to calculate this force of static friction. What else have they given me? They've given me my mass, 20 kilograms, and I think we're about there. So Really, I need to know the force of static friction. Do we have an equation we might go to for that? Yeah, we've got the fun equation. The force of friction static is equal to the coefficient of static friction times the normal force. Now, when we look at those two variables, the coefficient is given to us 0.5. We don't know the normal force yet. We do need to figure that out. So let's go back to our free body diagram. The normal force is in the y direction. What do we know about the forces in the y? Net force in the y is equal to all the forces up, normal force, minus all the forces down, the weight, and that's equal to the mass times the acceleration. Oh, what's the acceleration in the y? 0. So how do the normal force and the weight compare in size?
The same.
They're the same.
200
Oh, yeah. How do we find the force of gravity?
times 10.
Yep. Mass times the acceleration of gravity. So 20 kilograms times 10 meters per second squared, 200 newtons. So if the force of gravity is 200 newtons, what's the normal force? 200. Okay. Do I have enough now to solve for the force of static friction? Yes, we do. So the force of static friction is equal to the coefficient of static, 0.5. I know it feels weird not to have units, but times 200 newtons. When you use this equation, this is calculating the maximum static friction that can occur between these two surfaces with this normal force. So that's 100 newtons. Okay, we're pushing with 72 newtons. The force of static friction maximum is 100 newtons. Is 100 newtons actually pushing back right now? No. How much is actually pushing back? 72. Okay. So is it going to move? No, it's not. So how would I write that? I would say the force of friction static maximum is greater than the pull force. So no, it does not move. That's part A. Check that out, see if there's any questions. What could part B be? If I didn't ask this question, what could I ask? I could say, how much friction is acting on the block right now? You just got done solving for 100 newtons, but you'd have to recognize that it's not moving, so how much force is pushing back? 72 newtons. That would be sort of a tricky, slightly nasty question to ask, but we could. Part B. If the block is already sliding, find the acceleration. Okay, so 72 newtons was not enough force to get it moving, but we called a couple friends over. They helped push on it. We got the block sliding. The friends left, and now you are just still pushing with 72 newtons of force, but the block is now moving. How do I find acceleration in that situation? Is this a motion equation or a net force question? Net force, because they didn't give us any motion givens, any motion values. So let's see what we can do. Part B. So this is part A. Part B, we are looking for the acceleration in the x direction. Let's net force. So the net force in the x direction is equal to all the forces in one direction, the push force, minus all the forces in the other direction. It's friction, but what kind of friction now that it's sliding? Static or kinetic? Kinetic. Force of friction, kinetic, is equal to the mass of our block, whatever it is, times the acceleration in the x. Okay. So I solve for A. How do I get rid of mass? Divide. So the acceleration in the x direction would be that push force, we know that, minus the force of kinetic friction. Do we know this yet? Not yet. Divided by the mass, we know that. I need to know the force of kinetic friction. What's my equation for the force of kinetic friction? Yeah, it's the fun equation because it's so much fun to use. The force of friction kinetic is equal to the coefficient of kinetic friction times the normal force. The coefficient of kinetic friction was given to us, it's 0.3, unitless, times the normal force. That didn't change, it's still 200 newtons. What's 0.3 times 200? 60 newtons. Okay. So how much force is forward? 72 newtons. What's the backward force? 60. Okay. So can you see that the net force will be in the right, to the right? Yeah. So the push force, 72 newtons, minus the force of kinetic friction, that's what we just solved for, 60 newtons, divided by the mass that was given to us, 20 kilograms. What's the net force? 72 minus 60. 12 newtons is the net force. 12 divided by 20 kilograms. Calculator. What do we get? 0.75? Point 0.6. So 12 newtons divided by 20 kilograms, meters per second squared. So it's newtons divided. So a newton is a kilogram meter per second squared. When we take a newton and divide by kilograms, the kilograms cancel, and then you're just left with that acceleration, meters per second squared. Questions on this? Now, is this a big change from what we've already been doing? Not really. Only thing now what we can do